Welcome to our webinar, Wednesday, February 16th, 2022. Next slide. I'm Ed Gebauer, Concrete Sealants. I am the MC and host for the American Concrete Institute Central Ohio Chapter live webinar today. You can see I have on my ACI certification hat. During my career, I was recertified 7 times. Been in the industry since 1980, so most of the time I was a certified ACI Level 1 certified concrete testing technician. Next slide. So now that it is 11:45, we are going to begin our announcements. Again, we appreciate Intelligent Concrete LLC for providing the web platform. It's much appreciated. Next slide. If several in your office are watching from one computer, please send us a list of who is participating. If you use a handle that is not your full name, such as Laura's iPad, send us a note in the chat box with name and email. We welcome questions through the chat box. Next slide, please. So our credit module will begin at noon. A new solution for concrete ailments, progress on colloidal silica for concrete by Dr. John Belkowitz, PhD, PE of Intelligent Concrete. I'm going to read John's introduction. He is the Chief Technical Officer at Intelligent Concrete, specializing in concrete research, development, and education with a focus on nanotechnology. Before Intelligent Concrete LLC, he served in the United States Air Force, specializing in civil engineering. His tour of duty introduced John to a wide variety of concrete types and uses, which were dependent upon engineering practices of different host nation forces, developing nations, and disaster repair initiatives. John has worked in private testing laboratories on structural engineering and materials development projects to include the application of nanotechnology in concrete. He received his Master's of Material Science from the University of Denver and his PhD in Mechanical Engineering with a specialty of nanotechnology in concrete at Stevens Institute of Technology in Hoboken, New Jersey. We're thrilled to have you here today, John. Next slide, please. That's John's picture, and you will see him live on the screen in the corner. CPD certificates are available to ACI COC members and will be emailed within a week by Jason Cummins. I already got my certificate, so he's counting on the fact that I'm here for at least 50 minutes of live presentation. You can count on me, Jason. Next slide, please. Recognize the education committee members, which includes me, Laura Stroop, Jason Cummins, Jeremy Lewis, and Lisa Burrows. Thank you all for the efforts to create great content for our chapter, Central Ohio Chapter of American Concrete Institute. Next. Upcoming event is a webinar, 11:30 a.m., Wednesday, March the 9th. 2022. It will be presented by Robert Howe of American Concrete Institute of Detroit. The title is ACI 318 Building Code Requirements for Structural Concrete. Next slide. In April, we will have a live tour of the Forterra concrete pipe plant on Hall Road in Columbus, Ohio. We will begin at 8:30 with a pre-tour lunch, followed by a tour. If ever you've been in a pipe plant, a block plant, you will know that a pre-tour is very important because once you get inside, you often cannot hear yourself think with all the machinery. So that way we tell you what we're going to show you, and then we show you. That one will be a limited personnel. We will cap the attendance at 20. Next slide. Please join the ACI Central Ohio Chapter. Annual dues are only $25. Many of us started with ACI at the chapter level. I think it's great that ACI is one of the few national organizations that you do not have to be a member of the national organization to join the local chapter. I have on my American Concrete Institute Greater Miami Valley Chapter shirt, which is the Cincinnati chapter. I started there in 1980 and eventually joined ACI International when I became a board member, a secretary in about 1985. Next slide. ACI International is the leading authority for the development and adaptation of guides, codes, technical resources, education programs, and proven expertise for all involved in concrete design, construction, and materials. Please consider joining. The annual dues are $259. Next. You will gain free digital access to ACI practices and guides, ACI University webinars and on-demand courses, subscription to Concrete International monthly magazine, or e-access to ACI Structural Journal. Networking, Career Center, directory, conventions, technical committees. I'm a member of ACI 350, Environmental Concrete Construction, and it is a wonderful experience to go to a national convention. I hope you all take the opportunity to meet the people that write the articles. It was a big thrill. Many of us remember Bryant Mather. I met him one time, and it's just, you can't say enough good things about going to national conventions. Next slide. One of our key organization activities is ACI certification examination. ACI certification sessions are in person. The review is in person. Testing is in person on the following day. Mask and spacing are according to the facility policy. So this, we're excited that things are starting to open up and we don't have to do everything by Zoom, such as the review. Next slide. The in-person testing are held at the Ohio Department of Transportation Lab in Columbus, which is an amazing facility. In-person testing is also conducted at locations around Ohio. Next. The ACI Central Ohio Chapter needs your help to find supplemental examiners for the performance exam on day 2 of the sessions. You will get a complimentary lunch or a gift card for each examiner volunteer, and a complimentary meeting registration is credited to the examiner's company. We thank all firms who send examiners. Without your help, we couldn't do this. And if you are a newly commissioned ACI Level 1 certified concrete tester, this is a wonderful idea to be involved, to hear the class again, and to monitor the temperature test, the slump test, air test, rollometer, and we recommend it. Next slide. This is what we have going on in February. We've already done a field testing technician. We've got one coming up, or field testing on 10th and 11th. And then we have an ACI concrete flatwork finisher and advanced finisher at the end of the month. It's always a 2-day program. We are very careful with the chapter programs to not hit on the days when we are having ACI level 1, because we would lose all the engineers at Ohio Concrete that are administering the test, and we would lose attendance of all the volunteers who go to help out. So if you've ever wondered why our dates jump around just a bit, that's it. Next slide. Here's the opportunities in March. And you can see they have one every week. One is in Columbus, and you can see all the areas, other cities in the state where we move around to bring the testing closer to where member companies want it. Next. These are the companies who have sent volunteers. We certainly do appreciate it. If you look up there and you don't see your company's logo, let us know and we'll get it, we'll fix that. So thank everyone again. Next slide.
That's the last slide there, Ed.
Okay, well, John's going to be presenting now and you will enjoy this. I've known John for 4 years. Personally, I've known of him by his reputation prior to that. He will entertain you with some geek speak as well as some fuel spiel. John, we're welcoming you with a virtual round of applause.
Thank you, sir. Thank you very much. Okay. All right. Now I'm not going to share my video here until the end, so I can do a full screen here without any breakdowns. And as we go through, please start getting those questions. Don't wait till the end to get those questions out. Ed and Laura and I are going to be monitoring the chat window for any questions. And I'm kind of stalling because we've got a bunch of folks dialing in right now. So I'm trying to get them admitted before we start over here. Okay. Thanks for joining us today. I'm going to start taking Ed on the road with me. That was an awesome introduction. Like Ed said, my name is John Belkowitz. I'm the CTO over here at Intelligent Concrete, where we specialize in bringing new and emerging technologies out to the industry. And today, the purpose of my presentation is to give you a quick peek into what we like to call the magical world of concrete. Specifically, we're going to be looking at a new solution for concrete ailments with a focus on a progress report on colloidal silica for concrete. And I'm very excited. You've got my email down below. We're going to be posting this later, but let's dive into a roadmap before we get into the meat and potatoes of the presentation. First and foremost, purpose. We're going to go through a quick intro of the subject, why we should care, the motivation behind that. But, you know, I said meat and potatoes. I'm a meat and potatoes type person. Those are the three big ticket items, the three meat and potato items that I want you to walk away with. And if you don't get those items, you know, I want you to ask for your money back from Ed. But these three items help us set the foundation and then start building the frame of our house to tell a story with all these case studies. And then what we'll do is we'll open it up for any questions at the end. And already a first question, Jeff. We are recording this, so we will be sending this out later. So my name is John. I've been in the industry for the better part of 25 years now. Started in this industry when I had a full head of hair. Oh, it was awesome. I was, you know, my first experiences in civil engineering were afforded to me by the United States Air Force, where I was in a civil engineering squadron. Our job was to provide, prepare, and sustain bases as the platform for the projection of aerospace equipment around the operational continuum. And about 12.5 years ago, after doing my time in a commercial lab, working for a commercial materials company, going to university, putting those together, my boss and awesome wife came up with this great idea of creating Intelligent Concrete. And suffice to say, we're more than concrete enthusiasts. We have certain pillars, and our ultimate objective is to save the world with all the concrete in it. And what that means is we are technical representatives for the concrete industry, or as I tell our children, we are concrete superheroes. And with that, that takes us into the purpose of our presentation. Many, many years ago, Whitney said, and this was after a very tough project that we have, that our biggest problem in the concrete industry is that we are solving today's problems with yesterday's technologies. And, you know, we have somewhere around 600,000 concrete bridges in our national inventory, you know, establishing this $48 billion a year industry. That means $48 billion of new concrete goes down every year. And of that, 8.3 billion is put into our degrading our older concrete, our more mature concrete structures to deal with the maintenance associated with chemical and physical attack, the response to. And now I'm not saying concrete is broken. I'm a big fan of the material, if you didn't know that. But we definitely need to enhance concrete for durability to physical and chemical attack. And of course, there's this carbon negative initiative. All those things, we're only going to get there, in my opinion, with new and emerging technologies. Now, there are a bunch of much smarter people who have written some great papers. Ed was talking about them. A lot of these people you could see at ACI when you come out to our next conference, which is in Orlando in March. We got to start making plans for that. But there's a wonderful paper by Katie Bardaget, Kurt Von Fay, and the folks at the Denver Federal Center for the Bureau of Reclamation. And it goes into new recommendations for ASR mitigation. This was back in 2009. And at the front of the paper, Katie puts a very short list as to why we are seeing these issues with ASR. And she lists that we're using different types of cements that we were using decades ago. They're higher alkali cements, they're higher blane finances. You know, we have some of the best geological engineers, geotechnical engineers who helped us pick out some of the most awesome aggregate. And now, I mean, in some places we're not even using natural sand, we're using manufactured sands, and we're using potentially aggressive ASR potential rock or aggregate. And you couple that with, you want to say, ineffective pozzolans, pozzolans that we just can't get a hold of anymore, but those mature technologies that we used to hang our hat on, we just don't have those as readily at the same prices that we used to 20, 30 years ago. So the purpose of this presentation, the learning objectives, again, what I want you to hold me to is, first, we're going to define colloidal silica, look at some of the standards, discuss the material aspects of colloidal silica and enhanced concrete. After that, we're going to describe emerging ideas and research to increase resistance or prove that nanosilica or colloidal silica, increases resistance to chemical and physical attack. And finally, I told you we're building a foundation for, and then a structure to house these stories, these case studies. That's the proof in the pudding. So there's a lot more out there, but we're excited to show you a quick peek into that. All right, so let's start with the definition. So you might hear me sometimes go back and forth between colloidal silica and nanosilica. And to the untrained ear, it can be sometimes very confusing, and in a way, the terms are interchangeable. And when we talk about nanosilica, we can talk about this milky-like dispersion over here that's a liquid, and traditionally that's what we want to work with. Is we never want to play with dry nanosilica. We always want to use a liquid as if it's an admixture. But the difference being is the colloidal silica is a liquid dispersion of the nanosilica-sized particles. So it's, you know, you're oftentimes referring to the same thing. So when we say nanosilica, colloidal silica, oftentimes it's referred to as the same. And why we care about these technologies, these nanotechnologies, oftentimes people think it's a total replacement, and it can be a total replacement, but it also can be used to enhance our mature technologies. And if we want to compare the Class F fly ash to the nanosilica, you know, they're both spherical. They're both pozzolanically or silica based. The difference is that our nanosilica is 1,000 times smaller than the Class F fly ash that we normally use. And the purity of the silica goes from like 36 to 70% at best for the Class F fly ash to a nanosilica that has 99.8% silica purity. And for those of you who don't know what a nanometer is, that's a 10 to the minus 9th meter. And to give you a frame of reference, a strand of hair, obviously not on my head, but a strand of hair is approximately 100,000 to 150,000 nanometers in diameter. Okay, so what we get out of our nanosilica is pozzolanic reaction. Pozzolanic reaction in the same sense that our silica from the colloidal silica or nanosilica sized particle promotes the reaction, that pozzolanic reaction that develops that backbone of concrete strength, that superhero of concrete strength, the calcium silicate hydrate, at the expense of the calcium hydroxide. Now, what we get out of this is, we reduce crack length we increase particle to particle packing, basically void filling, and we create more, I said it before, that backbone of concrete strength to create an environment that is not conducive to chemical and physical attack. And if you had said, well, John, that's what microsilica or silica fume does, metakaolin, as well as class F fly ash, you wouldn't be wrong. So then the question is, what is so special about a nanosilica? And there's three things. One, with the nanosilica, we get this instantaneous pozzolanic reaction. There's a wonderful paper by Land et al. From back in 2012 that goes over, because of the size of the particle and the reactivity of that particle, there's a very specific surface potential to it. We see this pozzolanic reaction happening even faster. And what Land et al. Said, they called it a calcium silicate hydrate seeding effect. The second thing is, because there is so much of this reactive material that's ready to combine with the dissolved dicalcium and tricalcium silicate, the system needs a lot more of that parent material, that dissolved material. A wonderful paper by Bjornstrom from 2003, 2004, that goes into this accelerated cement dissolution. And that's basically, we get more bang out of our cement buck. I love saying that. That's why virtual meetings aren't great, because I can't hear the laughter that is going on right now, which I'm sure is at that awesome joke. But, that's one of our biggest problems with cement, is that we just don't get to use all of it. There's this M&M hard candy shell that kind of seals off, and it creates a diffusion barrier where, yeah, we're going to use it, but I mean, that's kind of why we try to grind it up more. With nanoparticles, to include nanosilica, we increase the dissolution rate of that one cement grain and get, like I said, more cement or more bang out of our cement buck. And then the last thing is heterogeneous nucleation. That's with all nanoparticles. Of course, nanosilica is the best, but with all nanoparticles, because there's such a small particle, and I've got this rudimentary illustration, there's a much smaller electrical double layer or surface potential or force field over the particle, over our nanoparticle. And because of that, these small things will force other things to grow on the surface. So yeah, those are the three things, that's basically grazing the surface when it comes to what is so special about nanosilica. And for that last one, that heterogeneous nucleation, one of Kim Curtis's student out of Georgia Tech wrote a paper back in, oh gosh, I want to say it was 2011, 2012. Not only did you have great wines from California in 2012, but you also had some great research on, colloidal silica for concrete. But in that paper, Jamal Jayalapan is talking about nano TiO2, which is an inert material, and he keeps making the titanium dioxide smaller and smaller. And ultimately what we see is, as we make that nanoparticle even smaller, we're increasing our degree of cement hydration, going through the idea that it's not a chemical reaction, but more of that heterogeneous nucleation effect that we're talking about. Okay, so let's get into the meat and potatoes. We've got the starting the foundation. The first thing that I wanted to do is give you a snapshot of where we are in specifications. Oh, so on specifications. So for ASTM, we've been using a ASTM C494, and we'll get into that here in a second. Sam, yes, I can make a bibliography. And what we've done over the last 4 years is to create a colloidal silica for concrete specification that gives the end users, the purchasers, the ability to identify that the material that they bought, the material that they ordered from the colloidal silica provider, is the material that was shipped and delivered to them. Now, bear in mind, this is not a performance-based specification. This is a specification similar to a microsilica, where we're looking for uniformity of material and to verify that you actually have a colloidal silica here and not what I like to call a very expensive salt water. So where we are on this new specification, I need to update this screenshot. It's WK60809. There is a light at the end of the tunnel, and it is not New Jersey. We are very close to our second to last, maybe one more, maybe one less than that, ballot to the main committee. I've got a chat with the chair today after this meeting. So very excited about us pushing forward and getting to that next gate for getting this colloidal silica for concrete specification. So right now, what we use is ASTM 494, which is the standard specification for chemical admixtures for concrete, which is a performance-based specification. It does give us this special performance admixture. And in that, you have your battery of tests that go on for a year. And because it's special performance, you have to do at least one more test to show what that special performance is. And in the past, what we've done is anything from abrasion resistance, water sorptivity, the permeability under water pressure, as well as alkali silica reactivity or even sulfate attack. So that's what we use right now to get through the specification products with a lot of our DOTs on their approved products list application or QPL. Oops. All right. Emerging research. So, Ed had said something about we're going to concrete geek out. Yes, I love geeking out to research. And Rich Seishi years ago made a comment that, there is a drastic difference between bookcrete, labcrete, and realcrete. And the person who knows how to go between those is going to be the strongest person on the team. And I like to pretend that I can go between those, but I tell you something, looking at emerging research and some of the new cool things that have been done that prove in a very controlled environment or give us the basic understanding. I love research for the sake of research, not just for the sake of commerce. So let's get into that. We've been working on a project at Oregon State University with one of the coolest cats in the industry, Professor Jason Weiss, and it's always been, blushing a little bit, always been one of my dreams to work on a project with Jason Weiss, and we're very fortunate to do that. Years ago, Jason created a test through funding from the Indiana Department of Transportation, the Colorado Department of Transportation, and I believe some other entities that was looking at accelerated methods to identify how well a binding matrix of a pavement would deal against the unfortunate reality that we deal with here in these colder environments, that calcium oxychloride formation from de-icing salt attack. And out here in Colorado, I mean, we use mag chloride, calcium chloride. We use a lot of de-icing salts, not just the government side, but also on the private side. So, and of course, Indiana is the same thing. So we wanted to follow suit with that research. And what I mean by that is, you'll see here when we get to the case studies, we've done a lot of research of not just bookcrete, labcrete, but also fieldcrete. And what we've seen over the years is nanosilica or colloidal silica, excuse me, is very, very good at enhancing everything around it, whether it's compressive strength, flexural strength, cement efficiency, permeability. And with that, we see resiliency to abrasion resistance, de-icing salt attack, ASR, so on and so forth. Oftentimes, we don't have a chance to ask why that's happening, or can we compare it to some of those mature technologies? Here, we actually get that chance, and it's not, just us doing the research. It's one of the most brilliant minds in our industry. So we're using Indiana materials. Our cementitious was Indiana sourced Bootsy type 1 cement, class F fly ash, as well as slag. Our nanosilica was provided to us by Specification Products, their E5 internal cure, as well as their E5 plus, and oops, that LFA, I've got to fix that over there. But all awesome nanosilica products. And the methods that we were using is ASTM 305 for mixing, and it was a neat cement paste. So we're not mixing up concrete here. That's one of the biggest things that we have to point out, is that this test that Jason and his team developed for the DOTs is an accelerated method, and it only looks at the binding matrix because it's really not the granular skeleton that we care about. The granular skeleton doesn't care about the chlorides as much as the hydrated cement matrix. So we're using ASTM 305 for mixing. We did our accelerated cure per Jason's or Professor Weiss's methods, and then sent them the samples for them to do their rock and rolling and their oh gosh, I forgot the name of the test. Low temperature differential scanning calorimeter test method. So it basically what their method looks for is two things: calcium oxychloride formation, and they're taking the sample, they're crushing it up, they're adding some calcium chloride, and then they look for calcium oxychloride formation, and they also look for calcium hydroxide. So throughout tests, and this is going to be published here. I think we submitted it for publication yesterday, day before yesterday. And I'm asking Whitney, I'm not talking to myself over here. But you'll get to see this, and I believe we submitted it to the Transportation Review Board. But in that research, you've got this figure which compares the calcium oxychloride formation to other materials out there. And in the paper, one thing that we point out is that silica fume and metakaolin are more effective than slag and flash in reducing calcium oxychloride. And of course, we used a control non-reactive material, something that more dilutes instead of the pozzolanic reaction. But when it came down to it, nano silica was found to be the most efficient at reducing calcium oxychloride formation. Now I want to pause for a second, and I wanted to highlight that. I don't care if you don't believe this information, especially if you don't believe the data here, based off of this comment, from some of those brilliant minds out there, even if I was a non-believer, would want to try out the material just to prove wrong. And what we have been finding is, we talk about carbon negative concrete, creating new, reducing the cementitious, that's great. But, to really go after those longer term structures and that are not just going to hang around and cost us money, create that $8.3 billion maintenance budget, we can create structures that not only last that 20, 40, 100 years, but can do so without costing us so much in maintenance. And that's what nanosilica has proven to do. And what I love about this research in that controlled environment, in a university setting, we're starting to understand why it does that. And what we found from this is the reduction in calcium hydroxide formation. But what we also think is happening is a binding of the calcium hydroxide that is still available for that calcium oxychloride formation. All right, let me get to the last part of this. So I'm going to go over 4 case studies, and we've already got some great questions. I'm going to hold off on more questions until we get to the end. This is the final stretch here. Case studies, 4 of them, and all of them, there wasn't just using the colloidal silica for the sake of using the colloidal silica. There was always some reason behind these case studies. And, pictures, they say more than the words do. And here in Colorado, we have a major issue with our mag chloride, just tearing up that concrete surface, reducing the service life and forcing us, whether it's residential or pavements, when we have the money, either rip out and replace or at least repair it. So we kicked the tires and lit the fires on this case study with one of the local ready mix providers. This is the mix that they already had in their arsenal. So we weren't doing anything to the mix outside of adding 4 ounces per hundredweight of our E5 plus nanosilica, the same stuff that we were using in the research with Oregon State. And what we did with this, we made about 800 samples with? Yeah, every time I tell the story, the samples, increase, but it was a lot of flipping samples. And what we did is we took a modification of ASTM 672, where our 4x8 cylinders now became the concrete sample that was now being soaked in our chloride de-icing solution for a 16 to 18 hour period, and then it thaws for 6 to 8 hours. And we did a mass loss on all of those samples over a 100-day period. And then what we also did is we incrementally broke those samples over time, compressive strength. And what we found, let me go back to this one, using the nano silica enhanced concrete, we saw a less mass loss compared to using the same concrete without the nano silica. And again, remember, all we did was add a small amount. And then the other thing was, over time, it wasn't just the mass loss, it was, we saw that the concrete with the mag chloride was becoming, or the conventional concrete was becoming softer, while the concrete with the nano silica, it kept gaining strength until a certain point. And, you know, please bear in mind, we're still dealing with chloride-based solutions that beat the crap out of concrete. And we got some great effort out of the nano silica enhanced concrete, but this was a failure scenario. We also did one of my favorite tests, ASTM 779 Procedure C, which is abrasion resistance of concrete. And this is something that is used by a bunch of DOTs. Ultimately what you're doing is you're taking your concrete sample, putting a 26-pound force underneath it, revolving 9 steel balls at, I believe, 1700 RPMs with a bunch of water. And you're measuring the depth of wear over a 20-minute span every 50 seconds. And basically what we see here is, you know, I made the statement that we noticed that the concrete was getting softer. And this is one of the reasons why I use the word softer, because normally when we want abrasion, or when we design for abrasion resistance concrete, we not only try to harden the cement paste or the hydrated cement matrix, but we also harden the bond, strengthen the bond between the hydrated cement matrix and the granular skeleton. So we almost create a better composite material when using this nano silica in the concrete. And this is not only at the quote unquote short term, but we also see this long term, 90 days. And man, we see some awesome benefit with the nano silica, and it's almost not even fair to compare the two. Second case study, this was part of my master or my PhD research. This was up in Eagle County, Colorado, at the Eagle County Airport. This was the first commercial application of nano-engineered concrete in the US. This is the mix that we were shooting for, 24 hours. We needed 3,500 PSI. This was on an active taxiway right in front of the air rescue facility. So there were no apologies if we didn't reach strength, and there was an in-flight emergency. Fire vehicles took off over soft concrete. So a lot of Portland cement, or a lot of powder here. We had to use 20% Class F fly ash. A big problem with ASR up in the mountains. The aggregate is so reactive, it almost glows in the dark. Again, laughter. The left mix is our reference, or our control mix. Again, we're using a small amount of the colloidal silica. In this case, it was by demand from the ready mix provider and the other folks working on the job site, where we needed to be able to round up to 20%. We were able to take out 6 fluid ounces per hundredweight of our high range water reducer. And we had a very low water cement ratio, again, because we're trying to reach that very high early strength with a 20% F-ash mix. We did 2 types of placement, hand placement and slip form pavers. And what we wanted to get from the contractors is, what was the feel? Was it sticky? Was it nasty when they tried to close the surface? Did it drag at all? Or was it creamy and dreamy and easy to finish? And could they put their lower skilled laborers on top of the slabs to close up the surface and get it pretty? Here's some of the properties. This job site was only 15 minutes away from the plant, but because we were going onto an airfield, there was about 45 minutes of checking around the truck. So by the time we got there to the placement area, you know, we had to add a lot of water to the reference mix to get it back to the slump that the team needed for a hand placement. Using the colloidal silica, what we found is, and this is not just us, Konstantin Sobolev from University of Wisconsin. Oh, I always get this wrong. Milwaukee, Madison, whichever it was, Konstantin Sobolev, awesome dude. He shows how nanosilica increases the efficiency of our polycarboxylate high range water reducers in a, I want to say, I don't want to say in a similar fashion to accelerators, but having that similar end result that we get more out of our high range water reducers. And that's what we're seeing here, not only initial slump, but also in slump retention. Again, we were trying to make that 3,500 PSI. With our reference mix, we weren't able to do that. And in all fairness, it got really flipping cold, you know, and the samples were on the job site. That being said, using colloidal silica, we see that it gives everything a bit of a kick in the pants. And we were able to not only meet, but exceed that 3,500 PSI at 24 hours. And what the quality control manager was afraid of is that it was going to have a similar response as using non-Colloidal or Colloidal-based accelerators, which is, you know, the later age strength dies off. And as it came down to it, it didn't. It exceeded what we were expecting. And you're going to see that same increase in cement efficiency used on job sites out in Indiana here in a moment. One of the other things that we had to do was look at the ASR potential. And I'm not trying to start a discussion on which is better, 1567 or 1293. Here we're using 1567, and this was a time when we were still looking at 14-day expansion in lieu of the 28-day 0.08 expansion, which is used nowadays. So again, using the colloidal silica, we were able to manipulate the molecular kinetics of cement hydration to create a concrete that was not just less permeable, but it's less conducive to that physical and chemical attack. And with that placement in Eagle County, Colorado, we were able to go back 7 years later. On the left-hand side, we have the same concrete, the control concrete that was poured without the nanosilica on the same day by the same team, adjacent to the concrete placed with nanosilica. Same mix, same team, same day, and a trained eye is not needed to see the difference. You know, the joke can be made that on the left-hand side, well, shoot, they got exposed aggregate. And, you know, people normally pay a lot of money for that, but that's just not the case here. What we're seeing on the left-hand side, when I say exposed aggregate, is 3/4 inch aggregate in the wheel wells or the wheel troughs of those heavy vehicles. And if you look at the nanosilica enhanced concrete, again, adjacent to, you're not seeing that exposed aggregate. When we take a closer look, you know, and I'm using a rudimentary scale here, some sunglasses, but it proves the point. And granted, the nanosilica doesn't look like it was poured yesterday, but this is 7 years later with the same heavy traffic, the same volume of traffic, the same de-icing salts and brines. And it was able to withstand that aggressive wear and tear, not only from the physical abrasion, but also from that chemical attack. And this is before we knew why. The next two job sites, I want to thank the folks at Specification Products. They really are awesome folks, and you'll see why here in a second. There's a lot of stuff going on at the Indiana Department of Transportation. You know, some great folks to include Mike Nelson, the PE over there, or Dan, I'm not getting choked up over here, I promise. Or Dan McCoy from RL McCoy are doing amazing things with the E5 nanosilica to not only increase the resiliency and enhance the response of the concrete to these abrasive forces, but also to go after that carbon negative approach. And, you know, I've hosted presentations with them just talking about their job sites, their courageousness, what they did to reinforce their courageousness with Purdue University and Luna Liu and her team. You know, the stuff that we're doing in Oregon State to support them, the stuff that we're doing. I mean, it's just amazing what these three entities, Specification Products, Indiana DOT, and RL McCoy, and whether it's bridge decking, pavements, or overlays, what they're going after is not just Class F fly ash replacement, microsilica replacement, cementitious reduction, but they're using more aggregate as well. They're enhancing the binding matrix so they can use more out of the granular skeleton, and truly pioneers of this carbon negative concrete, while being mindful of they got to deal with realcrete. It's not just paper, it's not just bookcrete and labcrete, but they still have cars rolling over, they still have de-icing salts and brines. So they've not only seen this increase in compressive strength, cementitious efficiency, but they've also seen increases in flexural strength. Here's a little bit of information about the bridge decking that they did on Highway 475. They started out, let me move this out of the way. They started out with a significant amount of powder, 658 pounds, using 3% replacement with microsilica. They took out 78 pounds of powder, took out the microsilica, and were using a combination of nanosilicas. And what they ended up seeing out of their compressive strength is an increase from 5,700 PSI to 7,200 PSI, effectively increasing their cementitious efficiency from 8.7 to 12.4 PSI per pound, reducing their cementitious by 78 pounds and still meeting the fresh and hardened properties. Now, bear in mind, they're doing this while keeping concrete pumped from A to B and lowering pump pressures. And if you're a concrete pump operator, lowering pressures and still keeping the same flow rate, that should be music to your ears. All right, the last case study. The reason why I love specification products so much, they donated 300 cubic yards of concrete to a local church out here, church that Whitney and I go to. Could not meet a certain budget for building a new facility, and specification products just swooped in and paid for 300 plus cubic yards of concrete. And it wasn't just your standard residential mix. It was a CDOT paving mix. It did have a reclaimed ash in there, and it was used for parking lots, curbs, sidewalks. And the biggest issue that they were facing is that they used a lot of calcium chloride salts for their congregations, and there was also a school on the property. So their concrete was constantly being torn apart, and they needed a concrete that they didn't have to worry about repairing, replacing in any way, shape, or form. And what we did is we contracted out a local testing firm, and a lot of this information is available for you. But again, SpecPro paid for all the third-party testing. This was not Intelligent Concrete. This was a local testing lab. And of all the tests we did, to me, this is the most telling. You know, this is why I say that we very excited that we're working with Oregon State University to understand the why behind how this is happening. But this is your standard ASTM-C 672 test. 50 cycles. I believe it's a calcium chloride solution. And we're taking a picture every 5 days. And this is at the end of the test. On the left is the same concrete as the one on the right, with the one small difference that we're using that liquid flash, that nano silica. Okay, before I open up the floor for any questions, you know, I often ask myself, why should everybody on this phone care? And, you know, I deal with a lot of government, Intelligent Concrete, we deal with a lot of government projects. And with those government projects, there's three different types of money. You have good to have, want to have, right? And then the last one is need to have. Right now, where we're at in the concrete industry is we're at that third stage. We are at the need to have for concrete technologies to respond to. It's either our cements are changing, our supplementary cementitious materials are changing, aggregates are changing, and our admixtures. You know, there was a certain mid-range water reducer that we had no problems getting up until this past summer. So there are so many changes. And as ready-mix providers, as contractors, as engineers, our job is to meet the demand without stopping. We have a population of 8.1 billion people, and it's ever growing. If we keep hustling today, we're still not going to be able to meet the recovery as well as meet the demand. So we've got an ongoing issues, a manifold of concrete problems. We've got limitations on mature technologies. Nanosilica has been proven by a lot of folks. If it was just me 15 years ago who was preaching about it, I get it. Be skeptical. But at this point, if you are skeptical, like Ed said earlier, there's an amazing amount of papers, not only through ACI, but there's some great people out there too who can answer your questions of this on this without any bias. I don't sell any nanosilica or nanotechnology products. I am all about the concept of bringing new and emerging technologies to the field, and that's what we're doing. Not only have we had the bookcrete and labcrete success, we've already had the fieldcrete success, that commercial success, and now we're communicating that to folks like you, DOTs, FAAs, commercial residential providers, everybody in the industry. And the reason why we have real world problems, not only on the de-icing salt side, not only on the ASR side, material resources, skilled labor, there are so many, like I said, a manifold of issues out there that as I open up the floor for any questions, I want to remind you of that quote. And again, I'm not talking to everybody. There are some folks who are on the tip of the spear when it comes to new tech. But as a whole, our biggest problem in the industry is that we are solving today's problems with yesterday's technologies. I want to thank you for your time, acknowledge the Colloidal Silica and Concrete Association, where you can find a bunch more material on colloidal silica and concrete. And through that, they host panel discussions with folks who actually use this in the field, who can answer your questions. And this is the last one we held, or I think this is the first one we held back in October. And then of course, you can always go onto our vlog and check out the myriad of movies or videos, excuse me, on colloidal silica for concrete, as well as other subjects. So yeah, at this point, I'd love to open up the floor for any questions. Ed? Okay, so let me see if I can get Ed to unmute, but I'll go ahead and
There we go. I'm unmuted. If you would look at the chat, there have been about 7 of them.
Yes,
Come in.
I'm going to start at Sam's question, which is the first one, I believe. Can you make a bibliography available of some of the research? Sam, when you go over to CSCA, the colloidalsilica.org, there is a list of publications in there with links. Some of them you have to purchase. Some of them are for free. One of them that is for free is my PhD dissertation, which looks at the impact of nanosilica size and surface area on ASR mitigation in concrete. And then a lot of those papers that I was talking about are in that list and more. The next question is, could this nanosilica be used as a supplementary cementitious content for marine concepts such as quay or armor blocks? How can supplement the durability of marine concrete? So absolutely, you would use this as you would use any other supplementary cementitious material. That's the reason why our ASTM is going to be in that same 0924 as silica fume and class F fly ash, or the 1240 and the 618. So yeah, you could totally use this for marine blocks, armor blocks, and you would just use it in your concrete production, 4 ounces per hundredweight to 8 ounces per hundredweight, maybe a little more. It all depends on your concrete mix design. And I tell you, the best way to go about that is when you're ordering, you look online using a Google search engine. When you're ordering your nanosilica from a company like Specification Products, their vested interest is to make sure that you're using it right. And they will help you dial that product into not just your labcrete, which is important, but also dial it into the field, that realcrete. So yes, it can be used, and we've done a lot of research that show that it can be used as a durability mechanism. Nick asks, for the Eagle County Airport project, how can you compare strength and durability between the control and test concrete when the control had a higher water cementitious due to the added water related to the slump? You know, Nick, I mean, that's an entirely fair question. And when it comes down to it, I'm comparing product that was used to product that was used. We have gone back and we did reduce the water cementitious for placements offsite. But again, we didn't use just 1 or 2 trucks. We gave that reference mix and that nano silica mix 7 trucks each. And that's published through Concrete International in an article called Colloidal Silica Admixture. So you're right. I totally understand what you're saying. In a way, it's almost like we're cheating the control. But again, outside of the fixes that we had to make, when it comes down to it, this was the standard operating procedure that when that mix got to the site, that control mix, they had to put more water in it to meet the objectives, to get that slump, that fresh property, to not only place the concrete, but also to close up the surface. And no matter how much more high range water reducer they put in there, because your same argument could be made for, well, there's a change in content of high range water reducer, and that could have had an impact on the setting time if there was, let's say, a hydration stabilizer in the high range water reducer. You'd be fair in making that comment. The concept is, though, we're using what was thought to be the best concrete product without nano silica and put it up against the same mix outside of a few alterations against the best concrete product. And then when it came down to it, when the best concrete product went up against the nano silica version, it could not measure up to the test of time. Hopefully I answered your question. Have there been any studies using nanosilica with PLC concrete and Portland limestone cement? That has become extremely popular, especially in places like Texas, here in Colorado, the Western US. And yes, there's been a lot of work done. I know there is a great amount of work being done in Indiana. We're starting work now in Texas. And it's the same process that you would use if you had to change from, you know, a cement from one provider to another. I'll give you, for instance, you know, here in Colorado, we're very fortunate that we have 4 cement providers. And when I used to work at Lafarge North America, and this was 20 some odd years ago, 20 years ago, you know, we used to have our cement, we used to come in, have one type of cement, or leave the day, have one type of cement, come in the next morning, and that cement would be drained out of the silo or emptied out or used up, and then a different cement would be added on top of it. And what we had to do was tailor, especially our high performance mixes that had very specific chemicals, we'd had to change those chemicals up. As it turns out, there are a lot of companies that are trying to create these one size fits all nanosilica products. The products in the company that we've been looking at so far have done a great job with that. But just like when you're using high range water reducers, there is a dialing in process. And of course, good concrete practices dictate that we always go after trialing this stuff before we go out to a commercial or residential application. Ed, those are all the questions that I saw. Am I missing any others?
John, there is 2 from Mark Party. MP is the symbol. How do you propose testing the permeability of nanosilica concrete mixtures? And how can that test result be compared to the maximum specified ODOT RCP test result of 1,500 coulombs?
You know, we just did a webinar on comparing electrical tests to physical tests when it comes to permeability. And I am a fan of the electrical tests. I think in our test, or in our webinar, we didn't use the RCPT, we used the bulk electrical resistivity, and we compared that to something like the ASTM 1585, which is that water sorptivity test. So yes, you can use the ASTM 1202 or the Australian version, which is like the NT 492, which is a little bit different, or you could use the bulk electrical resistivity. And for my research for my PhD, even for the research that went behind that job site at Eagle County Airport, we use bulk electrical resistivity. And I believe here in Colorado, Whitney, correct me if I'm wrong, we are now requiring for pavement mixes to use bulk electrical resistivity. Yeah, I don't know if that is as opposed to the RCPT or you could choose which one, I can't remember, but this is the point I'm trying to make. Just like a number of other supplementary cementitious materials, when you use something like colloidal silica, you can get a false negative, meaning that your conductivity value will be measured to be something much higher than the actual density or permeability or pore connectivity of the concrete. And what I mean by that is we've used a lot of permeability tests. Everything, I think I mentioned the ASTM 1585, C42 or C642, the DIN 1048, which I also believe is the BS 12930. Purdue is starting to do some mercury intrusion porosity. I mean, the list goes on. And we've also done like I said, the bulk electricals as well as the RCPT. What we have found is that just like getting false negatives from other supplementary cementitious materials like microsilicas or ashes or slags or metakaolins, there is a possibility that you can get a false negative, not only from colloidal silica, but other materials like carbon nanotubes. And the reason being is a lot of these materials have their own conductivity to it. And ultimately with the RCPT, we're looking RCPT, we're looking for conductivity, and for bulk electrical resistivity, we're looking for the inverse of that, or resistivity. And with both of them, if we have a very conductive material, the RCPT values will shoot up. Or if we're doing bulk electrical resistivity values, those values will drop down, not because of a change in percolation or the connection between pores, but because of those the conductive materials. Now, my recommendation for that is, and this is what I recommended to the folks here in Colorado, don't put one test on your people. There's so many flipping tests out there. Not only can you use an electrical test, but concurrently you can run a 1585. And 1585, that's a Tupperware with coffee filter test and a timer and a scale. Like, you don't need a university to do that test. And there are a lot of amazing videos out there that show you how to run the 1585. If for some reason you've never run it before and you want somebody to help you, get it started. So I love the RCPT, I love all the tests, but we have to use them in an intelligent manner, i.e. being cognizant of the raw materials that we're putting into our mix. Did that answer that? Hopefully that answered that question. What other questions do we have, Ed?
You've done a marvelous job of answering questions. As when we did the rehearsal on Valentine's Day, it was the joke was celebrate our love for all things concrete.
Amen. Amen. Amen.
And so if you would put up your slide about all the resources available through Intelligent Concrete. So if they didn't have a chance to see that, because it went pretty fast there at the end.
Right. And it's not just Intelligent Concrete, the Colloidal Silica and Concrete Association, and that is at colloidalsilica.org. There is a bunch of resources there, news, events that we're hosting. And I believe the next event that we're hosting is next week. And during that event, and you can see it on my LinkedIn page, during that event, and we're doing so many of these, we're going over how to tell the difference between colloidal silica and snake oil, because there are a bunch of them out there and it's not difficult to distinguish between the two.
Well, that's good to know. I mentioned to the audience that John will have some geek speak mixed in with some field spiel, and you did a marvelous job of that. And if you were out here, you would see that we're clapping, and actually you're getting a standing ovation, John.
Hey! Appreciate that, sir. And hey, listen, if anybody ever has any questions, we're going to be posting this as a video. I know I went through this quickly, but you're going to be able to get all of this information as collateral later on. And, please feel free to shoot me an email with questions if you want to challenge me on any ideas, or if you're interested in trying to get some nanosilica or colloidal silica and using it on your next job site.
Well, thanks everyone for attending. John, we would appreciate you getting us a list of who was here, because we have a number of people who are hoping for CPD certificates. So thanks everyone. We appreciate your time today, and we look forward to seeing you on March the 9th for another webinar. That will be ACI 318 by Robert Howe of the American Concrete Institute.
All righty, y'all have a nice one.
All right, thanks so much.